Afternoon all. Item of post here. Now, should I do this as post bag or shall I do this as some other format? I'm just wondering whether post bag should be one item opened and fully explored or lots of items opened and reviewed in brief. What do you think? Now, this item is from Frankie Tong. Frankie Tong is the guy who sells on eBay these rather wonderful USB power monitors. So what's in this bag? Well, it's a USB power monitor. Let's have a look. So here it is. It's in this rather unassuming black box, and at first glance you'd be hard pushed to tell this from the really cheap ones that you can get for a couple of dollars. But this is anything but that. This is really quite sophisticated. You can see that there's a button there. You might also be able to make out that there's a circuit board in there, and if that's wired to the main board, and this is a Bluetooth module, and so what you can do with this is you can transmit via Bluetooth to a smartphone or tablet the voltage and current readings as a constant stream of numbers, or at least that's what I think you can do. Also, the tech in here has been massively improved since the yellow and red ones, but why they've chosen not to go with these very distinctive coloured circuit boards, I don't know. It looks rather dull, doesn't it? So let's power this unit up. Now I'm going to do it side by side with the red unit. Now when I switch on, watch the splash screen. This one USB 2, this one USB 3. So that's the first difference. This is not a USB 3 unit, it's USB 2. And then on this first screen, the second difference you notice is that the black has voltage to 4 decimal places, and the red, and also of course the yellow, has voltage to 3 decimal places. Okay, let's switch to another screen. So on this display screen we can see that the black is very similar to the red in that it has the identification of D plus and D minus voltages to try and work out what the power bank in this case is signaling to the device being charged. They're both reading 2.76 on both pins, so they're both identified as Apple 2.4 amps. Now curiously there is a difference in voltage here. The black is reading 5.13. That's my power bank switching off. Let's switch that back on again. The black is reading 5.13. The red is reading 5.09. Now I would have thought that these two ports are wired in parallel. I don't know that for sure, but that's what I'd have thought. So let's switch the power bank back on. Now I'm going to flip through to the next screen. Now this is interesting because on the black one you have to press the button on the back, and the only way you can really do that is by obscuring the display. On the red one you press the button on the side, so the display is not obscured. So it is a bit of a nuisance having to press the button on the back, thus putting your thumb over the display. I mean, you can kind of do it without doing that, but it's not as easy because you really want something on the opposite side, that's the power bank going off again, on the opposite side to press against. So again, we've got this disparity here, 5.133, 5.091. Now these units can of course be calibrated, so if one of them is inaccurate, it hasn't been calibrated, that's a relatively easy thing to fix. And for the sake of completeness, let's go through all the screens. We've got amps to 4 decimal places, volts to 4 decimal places, the memory number, cumulative amp hours, cumulative watt hours. Let's change screen. Amps, volts, memory number, instantaneous watts at the bottom there, and average volts. I'm not sure why that's 0. We've got effective resistance of the load, temperature inside the MCU, that's the power bank going off. A timer there at the bottom, and on the bottom right, the current below which this thing won't accumulate data, so that if the power bank has a small parasitic draw when it's not actually charging, which I've seen some do have, you can compensate for that. Next screen is the identification of D plus and D minus, also showing an abbreviated volts and amps, the voltage graph and the current graph, and the large font volts and amps to 3 decimal places. Interestingly, if you press and hold on that one, you get the flip, which flips everything around the other way just in case that's more convenient. Now you might have noticed, and I can show it on the red one as well, but sometimes it doesn't always change screen when you press the button. See, that didn't change screen, didn't again. And sometimes you have to just press it a bit longer, that's gone to the off screen, to make it change. The one screen where it does seem to change very reliably is this first screen, and often you can get contact bounce on the switch there and completely miss that screen, and since it's one of the most important ones, that can be a bit of a nuisance. That's the power bank going off again. So certainly this button on all the units that are the YZXstudio units, the polling of the switch is not 100%. In the graphs, it can be quite difficult to switch it on to the next screen, I've noticed. So here it is on eBay. This is actually Frankie Tong's listing. Frankie Tong's picture is very nice, but it still doesn't give much away, does it? Just a black blob. Okay, so this is the USB 2 power monitor, black, YZXstudio, 18-bit voltage and current meter OLED display. It's $28.99, free shipping, and Frankie Tong's eBay seller name is FT2000. His eBay store is 99cent Hobbies. So next, I want to try this Bluetooth module. I want to see if I can get data, voltage and current data out of this unit and onto my Nexus 7 tablet. Now the Bluetooth module doesn't come as standard, but it's a relatively easy thing to add in. However, I'm pretty certain that you could also add it in to the red module and or the yellow module as well. I don't think it's exclusive to the black. Let's give it a try. So I've just loaded the same app that Frankie was using, this Bluetooth terminal, onto my Nexus 7. So let's just get that running. Now up here in the settings it says connect to device. Let's go insecure. Scan for devices. Now, although this thing has switched its display off, it is still running. That's obviously the device there. That looks like a MAC address. That's probably a Bluetooth style MAC address. And there it goes. Well, that was easy. So that's voltage and current. Of course, there's no current being drawn because I've got nothing plugged into the output of this. Actually, if I plug one of these into the output of this, that should draw some current, and yes, it has. Actually, this is raw data. This doesn't have decimal points, so since this is 5.1 volts, this is probably 0.0074 of an amp, about 7.5 milliamps, and that would make sense for the amount of power that the OLED on the yellow monitor is drawing and taking through the black monitor. So this is a bit of fun. Let's see if it keeps churning this data out while I roll through the various display screens. That's the watts one, that one, the dedicated charging port details, the graphs, voltage and current, and the large font display. And yes, it seems that the Bluetooth data comes out in all of those screens, even when the display itself is blanked. That's interesting stuff. That could be used for data logging. So I've taken the unit out of its black case, and now you can see the YZXstudio logo. Interestingly, if I put the black case back on it, you can barely see that at all. I don't really know what they're thinking with this black case. It's really not very nice at all. There is the Bluetooth module. That's just wired on with 3 wires. I suppose that's VCC, ground, and TX on here, and an RX on here. It's ever so simple, isn't it? It's quite interesting. I might take a look at these modules. They're obviously very easy to drive. Now, the Bluetooth module is soldered onto these pogo pin points, which you use for firmware upgrading. So you'd have to, if you wanted to do a firmware upgrade on this, you'd have to remove those wires, of course, and then you might have a little bit of difficulty. You'd have to smooth the solder off these reasonably flat in order to get the pogo pins to make contact. But anyway, here's the low value resistor, quite a nice looking Dale branded one for current measurement. This is, I'm assuming, a parameter E² prom to hold all the parameters. Mainly, I suppose, milliamp hours, the accumulated milliamp hours data, because of course this unit holds that data through the power off cycle. Now, I'm quite interested in what this microcontroller is. I mean, is it really 18-bit ADC? That seems extraordinary. The sun's come out, which is also extraordinary. It's a 32F030P4P... what's that? B? Let me see if I can get in even closer. No, actually it's a 32F030F4P6. I'm going to see if I can find that. Now, I'm going to interject at this point because when I first shot this video, from this point onwards, it all started to go a bit wrong because I discovered that the microcontroller in the black is exactly the same as the microcontroller in the red and yellow, and it has a 12-bit analog to digital converter. So I started to doubt the claim that this one has an 18-bit analog to digital converter, but it does, and here's the proof. It uses the microchip MCP3421 18-bit analog to digital converter. And so I owe Frankie Tong an apology because at this point I emailed him and I said, Frankie, I don't think this thing's got an 18-bit A to D converter because I hadn't spotted the microchip chip. He came back, it was about 4 in the afternoon, he came back and said, okay, I'll sort that out tomorrow. It's midnight here in Hong Kong. And but actually he came back pretty quickly, said, I've contacted the manufacturer and they say, have a look again because it uses external A to D converters. So he got in touch with the manufacturer after midnight and they had a conversation about whether or not this thing had an 18-bit A to D converter. That's extraordinary, and that's some indication of the kind of guy that Frankie Tong is. He really pulls out the stops to help you out.